Swayam Prabha. Digital India. Educated India.
Welcome back. In lecture 19, we will talk about object-oriented programming. The different concepts that we will cover will be on how from procedural programming we are moving into object-oriented programming. Then we will discuss why we require object-oriented programming, and then we discuss the basics of object-oriented programming or OOP, and then what is an object, what is a class, we will talk about those. Then we will talk about encapsulation and abstraction, what is the meaning of those concepts. And then we will look into the property of inheritance. Then we will look into the properties of polymorphism, dynamic binding, and message passing. Finally, we will end with trying to understand the benefits of object-oriented programming. So we have already learned this earlier, that is programming gradually evolved from codes written in machine language, which is zeros and one. Which was like almost, these are hardware level instructions, very difficult to code directly. So eventually people started trying to add layers of abstraction so that people use certain symbols or some things to which are represent a set of instructions and so on, and then you can repeat that. So assembly language was trying to simplify that from machine language, but still it was very difficult to implement, difficult to write code in that. So eventually we moved into procedure-oriented programming, where the functions, procedures, those were introduced, and we saw that declaration of variables, then programs were written as a series of functions. That means you get in data, then you work on the data, get some output from that data, and there were different functions to be called. So massive programs with hundreds of functions with connected, related variables going from one function to another. So a lot of problems were there in those kind of programming, right? Simple programs using a procedural oriented language is okay, but if you have a massive program, it really becomes difficult, right? So particularly till now in Python, what we have done is basically we are using functions and separate operations like arithmetic operations, Boolean operations. We have also learned some loops. These are all almost like procedure-oriented program. We have not yet introduced the concept of classes, but we will do that. But before we do that, we first want to tell you what is this object-oriented programming. Now, to appreciate what is object-oriented programming, that means where objects representing real entities are actually being that means we are writing programs where we represent the real entities on which we are trying to do something, right, in that particular set of instructions. So how do we reach there? So first let us understand the procedure-oriented programming, then only we can understand what are the problems, and then why do we need to move into this object-oriented programming. So procedure-oriented programming, few examples we know: C, then COBOL, Photon. This were procedure-oriented programming, and this image actually shows you the actual structure of the program. So we have a main program, and the main program we can declare some global variables. Then that can call a function A, it can call function B, it can call function C, B again call functions D, maybe A can also call function D. And in this way, different functions were related. There were some local variables within function B, but some global variables are also passed into function B. Then after function B changes them, it comes to function D, but then function D again changes them. So, it's tracking the movement of variables, tracking the sequence of steps becomes very, very difficult. So so we found that data is often global and shared across the functions. Functions did also have local data, but global data are vulnerable to inadvertent change by a function because because there are so many functions, what changes occur, it's very difficult to track them in a very large program. And then if you want to revise the data structure, that means instead there is a list and you want to change that list, right? So what happens is when you do that, it requires, you need to check every function that if there needs to be any change to handle that particular change in that data structure. So again, multiple functions directly call each other, making large systems very difficult to modify and maintain, because you have to track the movement of data, track the procedures that you have written, what changes is happening. So it's a, so that needed to be simplified. So why object-oriented programming? So in most problems in the real world include real challenges, real entities, right? Like for example, in urban planning, there are transportation system, housing projects, infrastructure management programs, and in each case we need to deal with these entities, and these entities are not that, sometimes these are very complex entities. They change over time. That means new data comes in, new data structures comes in, new functions are introduced, different tasks they do. So there needs to be continuous change, right? So if I ask these questions, how can real world entities be naturally modeled inside softwares or represented inside softwares, right? How can software systems be designed with clearly defined and open interfaces, so that I know what has to be changed, and if it changes, I don't need to bother about what happens down the stream if it will result in errors, because the structure should be such that that change should automatically be taken care of. How can modules be made reusable and easily extensible? That means if I write something, I want to repeat it. Yes, of course, earlier we were writing functions, we are repeating it. But can we have more than that? That means can we have these entities, like for example, we are talking about housing projects. Suppose there are 10 housing projects. Do I need to write code again and again, or can I repeat certain parts of it? So how can systems be designed to accommodate future changes with minimal modification? That means I don't need to change everything. I just need to change certain aspects of it. And then, of course, if software could be developed, we can improve productivity, we can reduce costs. So that is from the development side of things. That means if you need to write less code, of course, you require less programmers. It would be faster and so on. And more or less, we want to improve the reliability, maintainability, and the quality of the software. So these questions, required a new form of programming. That means the earlier procedural form was not adequate. So object-oriented programming eventually came into being, and object-oriented programming provides a structured paradigm to address all these above requirements by closely aligning software design with real-world systems, right? Now, how it is done? Now, for example, object-oriented programming decomposes the overall program or the overall thing that we are trying to solve by first breaking it into objects, right? Then what it does is, that means we would have several objects, right, or entities. And each of these entities will have two things in it. One is data and the other is function. Data are the attributes or the characteristics of those entities, right? For example, I am trying to design a building, then the data would be the height of the building, the number of the buildings, the land use type, right? I'm trying to do some program which relates with building stock calculation or building FSI calculation, area calculation, something like that, right? So of course, the data would be the characteristics of the building, and then the functions, that means the methods that will operate on that data, will be also part of that object. That means both data and functions are taken together, and together they form that particular object. So, and data of an object can be accessed only by the function associated with that object. So that means it's like, the data is local and we are able to utilize that data within the function. However, so that means no other object or no other code line can directly access the data within my particular object, right? However, functions of one object can access the functions of other object, but there is a way to do that in a proper, safe way, right? One function can access the function of another object, but it is not getting access to the data directly. That means it is sending calling another object, function of another object, passing some argument to it like we have done earlier, and then getting a result, right? So that means you are not getting access to the internal data of that particular object, right? So a building object in this particular case, what we are doing is, of course, if you want to do that, you have data like the attributes, which we have already talked about, and then there are functions to calculate FSI, check height limit, and so on. So the building is designed around its data and not around its function like in procedural programming. So the emphasis is on data, not on procedures. That is, data structures are designed to characterize the object, and then we have functions to work on the data. Now, programs are usually divided into different objects, and these objects talk to each other, the objects relate with each other, and data and functions are bundled together inside these particular objects. And data is obviously in that case protected from direct external access, so nobody can directly change any data inside an object, and objects communicate between themselves via well-defined interfaces or via functions, which we will explain later. New data and functions can be added anytime, so that means you don't need to rewrite everything, you just need to add new things, and that will not affect things which are already written, and this supports bottom-up system design. So what is an object? So objects are basically runtime entities that represent real world or conceptual items. Now, for example, in this particular image you can see object A, object B, object C. Object A has its own data, its own functions, object B has its own data and functions, and so on. Now, object A and object B can talk to each other, of course, and then how they do it? They will do it via the functions, right? So what happens is, when the program is run, objects are created dynamically, the functions are performed, tasks are done, which is the part of work of the program, and then when the task is not required to be done, it is destroyed. That means the object is destroyed, that means it is removed from memory, and we create new objects which would be required. So what we do over here is, each object encapsulates its own data and function, and the objects interact through bidirectional message passing without directly accessing each other's internal data. So that means what kind of message would be accepted and what type of response would be returned by the objects, it is only known by the object to which I am sending the data. That means whichever, suppose function of object A is calling function of object B. So function B determines what data needs to be passed to that and what response it would be returned, and that would be accepted by the function of object A, right? So that means there has to be proper interfaces designed. But internal data, internal processes, what is happening in function A, this function in object A doesn't need to know all this what is happening in function B. So object A can send a request to object B can send a response or request back to object A. Neither object directly accesses the other's internal data. For an example, let us assume object A is traffic management system, object B is a road network object. Now traffic system asks the road object that what is your current capacity. Now that means it is trying to access the function capacity within object road network object. Road network object gets the request, capacity, it checks the capacity using the data, internal data, that what is the volume and so on, and it says that capacity is reduced due to peak hour, and this is what is being returned and to the traffic system, and traffic system can take a decision based on this data that it got, that okay, capacity is reduced. Traffic system cannot access road data directly and request response via a function. Now that we have understand what is the basic of this objects, that means in object-oriented programming, object is the key. That means in real time we are creating objects and then we are destroying them, and these objects interact with each other. The objects have got data, functions, and so on. But where are the objects coming from? How it is being created, right? So that is where classes comes in. So an object is basically an instance created from a class and represents a usable entity in the program. That means objects are almost like variables of type class. That means like object is the structure and we can make multiple copies of that particular structure. So class is the structure, and in object we can make multiple copies of that or multiple variants of that particular class structure. So after defining a class, we can create any number of objects, all sharing the same structure and behavior. From a building class, that means we can create a school building, we can create a hospital building, we can create a residential building, because building class probably has got a structure where there is building height, building floor area, and few other properties, right? So when I say school building, I will say, well, that's a floor area is this, total height is this, users are school children, and so on and so forth, right? So I can define, we can put the actual variables in that structure and can create that object which is a school building. Now every object stores its own values, but the data fields and functions are defined by the class. So the overall structure is given by the class, like what sort of data attributes, what sort of function, but the values that would be stored would be specific to a specific object. In some way, a class group together objects that share common characteristics and behavior. So that means when we define a class, basically it is a something which is grouping many characteristics together. Like class could be fruit, objects could be mango, apple, orange, and if you look into the properties like how sweet it is, what is the shape of it, this will vary as per that particular fruit or that particular object in this case. So when we learn object-oriented programming, we have to understand some characteristics or some core concepts. Out of that, of course, the first main concept is the concept of objects and classes, which we just covered. Then there is a concept of encapsulation and abstraction. Then there is a concept of inheritance, polymorphism, dynamic binding, and message passing. So we will learn each of them one at a time. So when we talk about encapsulation and abstraction, we already have discussed to a certain extent about these properties. Encapsulation basically means binding data, in this case attributes, and the methods that operate on the data into a single unit called class, and restricting direct access to the internal data for other parts of the program. So that is what is the concept of encapsulation and abstraction. So the way a class is constructed is based on this particular property. So the object controls its own data, and external code cannot freely change internal values. So whatever is happening in the class is very internal to the class. External code cannot change this. And interaction happens only through well-defined methods, that is via function calls that between the objects, right? And this prevents accidental or unauthorized data modification and improves reliability of large systems and makes debugging and maintenance easier. So that is one of the reasons why we moved from procedural programming to object-oriented programming. Abstraction refers to the act of representing essential features without including the background details or explanation. So that means whenever I am using a function of a particular class, I am calling that class dot function name. Usually that is how it is done. Like in the example that you see in the below, it is a program related with travel demand estimation. It's a travel demand model. So what is happening is model.run. Model is the name of that particular object, and we are trying to run is the function within that, right? So I am calling that run function by calling that first giving the name of the object and then putting a dot, right? So this is how I access that function. Now when I am calling the run function of the model object which belongs to a particular class, I don't need to know what is happening inside that. I just call that, I know that run will do this, and automatically it executes. Similarly, when I am using this particular function get.odmetrics, I am not sure about which algorithm is used inside, what is the convergence criteria whenever we do this OD metrics and we try to do trip distribution and all, there is something called a convergence criteria in transportation planning. So that is what I am saying, that I don't need to know the details of what is happening. I just call the function and I get the results, right? So that is how the abstraction actually refers that only essential important information is revealed. That means which data parameter needs to be passed, what data is returned. I don't need to understand the background or details. So that is how the object-oriented programming is done. The focus is on what the object does rather than how it does it. And only essential features are shown and implementation details are hidden, thus reducing cognitive complexity. So as a programmer, you don't need to bother about what is happening in the at the back end. So in Python, this is very important because we have so many libraries, so many functions. You don't need to understand the working of how everything is done. For example, if you do linear regression, if I teach you linear regression, there is there is a lot of statistics at the back end. How do I actually go about the process? But you don't need to do. You just have a data set, you apply linear regression, you get the result. So that is how Python works, because or any object-oriented programming works. You don't need to know about the internals. If you are interested, you can, but for daily use, you don't need to know that. Now, the next very important property, this is the property of inheritance. Inheritance allows a new class to acquire properties and methods of an existing class. That means I don't need to build everything fresh. I can use an existing class and I can add something more to it. So this is also very fundamental, thing that because we have got so many libraries and all and so on, we can use their functions and so on. And similarly, we can use some of those classes and we can also enhance those classes, right? So to give you an example, we can create a general class and then we can derive many more classes out of that by using this property of inheritance. So this allows use of code, and it supports hierarchical classification. That means it organizes the classes or the objects in a little hierarchy, and it also allows extension without modifying too much amount of code, because here these are very simple examples, but a program could be of 100 variables and then there could be 20 functions, right? Now if you want to rewrite everything, that would be cumbersome. So you use that, plus you add some addition things and you give it a new character, right? And it becomes a new object. So over here you see a building object which has got attributes like height, floors, plot area, and two methods to calculate FSI and to check height, which we have already learnt earlier. Now I create new classes which are inheriting from the building class, and there are two new classes. One is residential, one is non-residential. Now in residential building, this has got all the attributes and the methods of the building class, plus we are adding a new attribute which is called dwelling units, and then we are also adding a method called estimate population. Similarly, for non-residential buildings, we are using an attribute called built up area and a method called estimate daily users, right? Now traditionally residential building means houses for people and non-residential means all other kinds of buildings, right? But over here we are trying to just show that in residential buildings people stay. So there could be a school where people stay. That means they are there for maybe it's a hostel as well, so they are staying, or there could be a hospital, or you can even consider residential building as one class, and then all the school, hospital, office building as different types of non-residential buildings, and these are inherited classes from that, right? So you can go to office, you can see that employees is one new attribute, and a new method is estimated peak trips, which is in addition to all the methods and all the attributes that was there in the previous this non-residential buildings this part, and this automatically includes all the attributes and methods of the building class as well. So this is how inheritance works. Now polymorphism is another very important property. Now what it does is it allows the same method name to behave differently depending on the objects. Now what is the benefit of this? That means the same function name is called, but it acts differently based on in what context it is being called. That means if the object is different, that means for suppose for two numbers, the operation when I say that addition operation, we can generate a sum, right? But if the operands are strings, in that case the same function which is adding up can generate a strings by concatenation. That means it can produce a third string by concatenation. So in one it is a numeric addition, in the other there is string operations and string addition, right? Now which one will be called depends on the context, depends on where this has been called. I will show you examples in the next lecture. So then what happens is, that means the benefit of this is whenever I am running programs in a loop, that means I am running functions in a loop, as per the context, the same function is being called, but in the loop, but because the value that is being passed to the function is changed, automatically the calculation also changes. Then comes the property of dynamic binding, which says that dynamic binding means that the method to be executed is decided at runtime and not at compile time. So this is the first thing, and that means we choose that, okay, which program or which function would be executed. Is it the string or is it the numeric one during runtime? Not we are not compiling them before we start the program. Earlier days, people used to compile programs. They used to write a code. They used to compile the program, convert it into machine code, and then there may be some errors and all. They want to correct it and then again compile. They keep on doing that. Now, dynamic binding allows us that, okay, that means whenever we can do compile, of course. That means during the compilation, we don't need to, that means which of the methods would be executed and all. As per the requirement, it would, compile and then save it. It's not like, that means we have to have different, এই জায়গাটা একটু ক্যান্সেল করো তো, ঠিক আছে, ডাইনামিক বাইন্ডিং থেকে আবার শুরু করছি। ওকে, so next comes dynamic binding. Now here in this particular property, dynamic binding basically refers to the point that if we are writing different methods and they are executed, that means which method will be executed will be decided at compile time. Now this allows different objects to respond differently to the same method, and actually this is supporting the case of polymorphism. Finally, we come down to the final property, which is message passing. Again, we have discussed this earlier. That means objects communicate between themselves by sending messages or method calls. That means we call a particular function of another object and we pass arguments. A message to an object is a request asking the object to perform a specific operation. And when an object receives a message, it executes the corresponding method which is being called and then produces the required result. And this message passing involves specifying which object should receive the request, which method should be invoked, and what information parameters should be passed along with the request, and eventually what message and what would be returned to the calling function at the end of it. So over here you can see the traffic model dot update flow road segment. So these are, traffic model is the object, update flow is the method, and road segment is the argument which is being passed to the method. So this is what is being done. Road segment is actually coming from the object which is calling this particular function. It may come from that object. So to summarize, what are the benefits of object-oriented programming? Of course, the property of inheritance reduces redundancy by enabling reuse and extension of existing classes, and programs could be built using reusable, well-tested modules, and because those are well-tested and all, we can do it faster, and also we can improve productivity, and the data is hidden, which enhances security because of encapsulation and abstraction, and this prevents unauthorized access to the internal data of those objects. And we can create many instances of the objects which can coexist in the program. So that means we have one class, and then we can create many objects of that, which allows us to do very agent-based programs and this kind of programming, right? And then real-world entities can be directly and naturally mapped to program objects. So we create a new entity, we destroy it as per the requirement, right? And we can have several, because we have several objects and all. Several people can do, several teams can work on different objects, and parallel development can happen. So this more or less the design is determined on the data structure, how the objects are organized, and this makes it more realistic and make it more real to the real world models or the aspects that we are actually trying to solve. And then object-oriented system could be easily scaled from small applications to large systems by adding on objects or adding on more functions to those particular objects. And then message passing simplifies communication between components and external systems. So I can easily call functions of other objects and so on without bothering about how the data is moving, how we are changing the variables and so on. And overall software complexity is reduced, making the system easier to understand and maintain. So these are some of the references I have used. And to conclude, object-oriented programming models software systems as interacting real-world entities, enabling reusable, extensible, and maintainable designs that scale effectively with problem complexity. Thank you.